The grid connection process itself has effectively not fit for purpose, and therefore there's been a clear driver for several years now to innovate that process, not from a technical innovation perspective, but a process one. We're essentially reforming the grid queue. So this is, I guess, it's a quintessentially British problem, isn't it? Because it's all about queuing, yeah. And we're moving from a world which was first come, first served, and we're moving from that world to a first sort of ready, first connected.
Hello and welcome back to the Hypercube Podcast. I am joined today by Catherine Cleary, who is a grid connection specialist from Roadnight Taylor in Glasgow, which is always great. Catherine, thank you for joining us.
Oh, thank
you. Would you like to explain your role, what you do, Roadnight Taylor, for our audience, please?
Yeah, sure. So I'm an electrical engineer and I've spent the last sort of 15 years or so working in primarily in the sort of renewables industry, so connecting large projects to the grid. So that might be, an offshore wind farm, a large solar farm, an energy storage project, could be a data center or a hydrogen producer, so both demand and generation. And that's what Roadnight Taylor specialise in. So we're a kind of a really sort of niche consultancy who help those customers who are trying to connect to the grid kind of navigate that process, right from applying to the grid to actually building out and energizing that connection, and then maybe problem solving issues which come up on operational projects. So that's us.
Very interesting, isn't it? And it's one of those, I often think, like, consultancies are essential in those parts of the universe where it never sits still for long enough for like standardization and like automation. I guess like in grid connection, it's like engineering, kind of financial systems engineering. Like, how does that kind of nexus of skills play out and help customers and shape what you do?
Yeah, I think, you're definitely right. I think that the consultant sort of thrives, don't they, in an overly complex industry where everyone thinks I'm a bit lost here. And it probably gives the game away if I've been doing the same thing for 15 years and I still find it fascinating, which either means I'm a massive energy nerd or it's genuinely quite interesting and evolving. I think, grid connections in particular is a space which is really, really technical. So our power system is evolving incredibly. We have moved away completely from the grid that we built in the 60s, and we now have a far more diversified and distributed energy system. So we keep building infrastructure, which is really interesting from a kind of engineering perspective, but commercially we've also carried on, reforming and regulating that grid in a kind of really quite radically different steps. So I think that kind of commercial, technical and regulatory sort of combination is really hard for any one developer to sort of have covered on all fronts at any one time. So we tend to work with quite a lot of customers who are really established entities in this market, and so they might have that sort of legal commercial piece completely down, but they might be going, oh, actually, we're stuck on this particular technical issue. So we tend to kind of like coming in and sort of doing a bit of strategic problem solving for customers on whichever of those sort of three issues crops up.
I guess like recent years, there's been an influx of, especially in, like, we spend a lot of time in BES, there's been an influx of new developers, like new funds they're trying to do things with maybe limited experience in deploying infrastructure and like actually trying to treat these as typical kind of financial investments and then having to rely quite heavily on third parties. How has that impacted your work? Do you see a lot of that?
Yeah, I mean, I guess I could kind of break down, we work quite heavily with three different types of end client, and that might be what we call like a pure play developer. So that could be someone who develops battery storage or solar farms, and they're really good at developing, right? They go and knock on the farmer's door, they find good land, they get it through planning, they get the grid connection, and they're basically packaging a project which someone else who's not very interested in doing that sort of slow initial groundwork can then just come along, fund and build. So there's kind of pure play developers who tend to actually have really kind of core strengths in terms of understanding the grid connection process and the regulatory process, but might not have a big engineering team because they don't build it. So there's pure play developers. There's the kind of owner operators, which are the big household names you'd probably think of. So when you think of like RWE, SSE Renewables, their office just down the road, haven't they? You think, oh, actually, these are the people who own wind farms or own, battery storage projects. So those owner operators will typically have significant in-house resource, but they might want an external party to do things like technical due diligence. They'll often be buying those schemes and wanting to make sure that they're good. And then we've got the kind of third, which is the sort of institutional investors who are really just the money.
Yeah.
And they're sort of sitting there going, Catherine, I don't really want to know about a voltage control problem or any of it. I just want to know, is this a good investment? Actually, does it have a bankable route into the grid connection process? So those three different sort of client types have three quite different asks.
And I guess though you must, because there aren't many vanilla projects left. There's a lot more behind the meter, like the industrial commercials becoming a bigger and bigger focus.
Co-location.
Yeah, co-location. So like multi-party and all that kind of headache, that must get fun, right?
Yeah, I think two things happened. Yeah, the commercials got harder. If we went back 10 years, we were in a world where ROCs were just ending, so renewable obligation certificates. It was quite, if you could get your solar farm through planning, it was quite a nice cushy commercial ride after that. That's changed. So I think there's a real drive for developers to come up with more complex projects which add revenue streams. So they've got a better kind of route to market for that project. So that might be like co-location, that often kind of say a solar farm and a battery together. Increasingly now it might be a data center and a battery and a wind farm together, so that kind of like adding elements to the mix, and that increases the technical complexity of the grid connection that you need. So that's really interesting. And I think the other thing is that actually, even if you did just want to build a nice vanilla wind farm now, the grid process that you are going to have to navigate is so much more complex. So the low-hanging fruit of sort of saying, could I just cable back to the substation that's near my project and connect? That's kind of gone. The answer is no, it's all full. And actually, you're waiting for significant reinforcements or kind of, complex sort of negotiations about where new substations are going to be located. So that even if the projects were still simple, the grid route has become harder.
Yeah, no, and I love it. Like we had, so Bridget Hartland Johnson, who's now a non-exec director for Hypercube, she was on and she was talking about how she, like, while she was at Orsted, developed the first co-located offshore wind farm BESS site. Like, because, within the boundary of the site, it was co-located, but because of exactly that, the constraints on the grid and the way, like, how do you make this achievable and how do you do it? And I think it's...
And Orsted are still leading the charge on that. I should probably give them a shout out because they have been doing some really interesting thing about co-locating BESS behind, like, the off-tow network that connects an offshore wind farm, which is really interesting regulatory challenge.
I think, it's just, like, fascinating to see, because that's, like, innovation of a different kind. It's like sort of challenge what's possible, not there is new technology involved, but not necessarily like inventing new stuff, but just like doing stuff harder and differently to enable things that otherwise wouldn't be.
I think we're going to see a lot more of that because, well, effectively, I think like we can come on to it because you and I have discussed it a lot, Adam, but the process is a bit broken. So we're going to talk about connections reform, I'm sure, but the grid connection process itself, has effectively become not fit for purpose. And therefore, there's been a clear driver for several years now to innovate that process, not from a technical innovation perspective, but a process one.
Yeah, that was my next question was, you obviously must be a huge fan of grid reform and it must do work for you. And
the gift that keeps on giving.
Yeah.
Yeah, I mean, I think, so for anyone who doesn't know, connections reform or grid reform we're essentially reforming the grid queue. So this is, I guess it's a quintessentially British problem, isn't it? Because it's all about queuing. And we're moving from a world which was first come, first served. So literally, if you wanted to connect your project, it didn't matter whether you were a hospital, a data centre or an offshore wind farm, you stick in your application to say, network operator, please connect me. And you sit in the queue, and you wait until you're kind of at the top of the queue to be connected. And we're moving from that world to a first sort of ready, first connected. We've stuck in first ready and needed. And what that's meant is that, we've had so much queue growth over the years that effectively we're now going back and retrospectively sort of sticking that queue in a sieve, shaking the sieve, and projects that were in the queue that don't meet some of the criteria. So that might be the readiness part. Yeah. So if they haven't got, land rights yet for their project, or maybe they haven't yet got planning and they're in a very kind of oversubscribed technology pot, then they fall out of the sieve. and sorry, goodbye, you don't have a queue position anymore. And if you're not needed, so that was the other kind of element. So well, who's needed? So the government have very ambitiously come up with a plan as to what kind of generation types are needed and how much offshore wind do we need versus solar versus do we need any more gas? And they've sort of set these caps essentially, and if your project is over that cap, so we've got more battery in the queue than we need, then some of those batteries fall away. So that piece of grid reform is pretty massive. That is basically the biggest reform we've done in the grid connection sector for the last 25 years. So it's a big task. It's been going on for really quite a long time. So we've been talking about this for sort of 2.5 years now. And I think it's probably fair to say it's not going very well.
No, and lots of strong opinions from everyone you meet and speak to, because it has a huge impact, right? But it does, like the way like you've just sort of summarized it there is really good. It does beg the question: is it ununderstandable? Like, what's the definition of needed? What's the definition of, like, are they going to say no, you can't have your hospital for another few years? Like, and how does it, like, you go from suboptimal, but first in, first out, like, there we go, everyone gets it.
It's kind of a market as well, you know, like that. There was a clear process.
And you get secondary products where you can sell on your place and all this stuff, to something that's really just like, oh, last the magic 8 ball and that'll help. Like,
NISO would absolutely disagree with the 8 ball analogy, I'm sure. They might disagree with my sieve. But I suppose I do think it was needed. I think that's for a very
no, I agree there.
It's like the analogy that I always use to my husband is, it's as if you go into a supermarket to do your shopping and you can already see that the queue is like reaching round, all of aisle 1 or something. So the first thing you do is you send your husband to go and stand in the queue whilst you do your shopping, and then by the time he gets to the front of the queue, the place in the queue itself becomes valuable if the queue is big. So you get to this complete catch-22 situation where, we want to reduce the size of the queue to make it a bit more manageable for the transmission operators to be able to plan the network. Because if they've got a queue, which is, and roughly speaking, the numbers, we have about a system demand of about 50 gigawatts in this country. So that means, worst case day in the winter, everyone puts the kettles on all at once, maximum demand would be about 50 gigawatts. We usually expect to kind of need sort of 80 to 100 gigawatts worth of generation coming on, in the next few years, in order to be able to meet that with a broader range of intermittent generators. So if all of our generators were gas and nuclear, you only need 50 gigawatts of generators to meet 50 gigawatts of demand. But if it's, wind farms, solar farms need a bit more. But it's that kind of order of magnitude. And we had a queue, which is about 750 gigawatts. So it is, it had got out of hand. And that meant that, every time, because you were putting your place in the queue and asking a network operator to give you a grid offer, they had to do all the network studies to work out, okay, what do we need to reinforce or build to facilitate this 750th gigawatt, even though they were going, well, this is bonkers, we don't need 750 gigawatts. But they kind of did need to do something. I think the needed part, so the ready part sort of makes sense. They did consult the industry. So I guess the grid industry is quite democratic in some ways. We do it all via CUSC modifications. That's so if you have a grid contract, you're able to sort of vote in things to kind of I guess effectively elect a representative body that then kind of administer the CUSC, and anyone can suggest changes. So there was a lot of industry engagement on that, and the industry did kind of get behind this whole concept of what's a ready project, and we settled on, okay, well, you need to have land rights, so you need to be really specific that you're trying to build a battery here. You can't just say, I'm trying to build a battery somewhere. By the way, it might not be a battery, it might be a data center, and so they've locked it down to say, actually, it's you have to apply for a specific technology, specific land, you have to have those land rights. That seems like a really good step. And then the needed part, I think, is more opaque and therefore more controversial. The hospital, by the way, at the moment would never be told you're not needed. So needed is a criteria which effectively only applies to generation. So we're open to demand because I guess demand is the economy, right? The grid is here to serve demand. So the needed part was to make sure we didn't end up with a queue that was just filled with batteries or just filled with offshore wind farms, because that doesn't give us the mix we need.
So plan a hospital to get your solar farm into the queue at the right stage. Build a massive hospital.
I think that's a level of innovation that I haven't seen anyone adopt yet. It would be I'm sure the NHS would be very happy with that.
It feels like it could be worthwhile. Might be onto something. I guess, how long does if I'm in that, I just want to develop my site, I want to go, and I don't get it. How long does it take to come knocking on Roadnight Taylor's door? Help! Like, how long does it take to get that answer and support me? And what's the impact? Are people making go no go decisions based on? Because I've heard like they are.
Yeah.
And how much can the needle get moved? And
yeah, so I mean, this is really fundamental, because if we sort of talk about the old days and the kind of new world post connections reform, in the old days you would come with your project. So you've got a project, you might not have planning consent for it yet, but you've got a clear project definition, you know what you need in terms of your grid connection, and you make the application, roughly speaking, within 6 months, so about 3 months, for them to kind of assess your application. They would give you a kind of commercial offer back that says, we can connect you. They can't say no, by the way, they have to say how much and how long. So they could say, sorry, Adam, not till 2040, but they couldn't say no, not at all. So they'll tell you when would they be able to connect you and how much would it cost, and you would make a decision about whether that was viable for your project. So that's the kind of old world, and that, if you then accepted that contract, you're in a contract with, it might have been with NESO if it was a transmission connection, or with your local distribution network operator if it was a smaller distributed connection. You're in a contract for that connection, and they're effectively obligated to deliver that connection. In the new world, what we're saying is we're basically bringing in, we're calling them gates. So, and it's like, it's like having to clear a hurdle. So in order to get that level of certainty and enter into a contract, you need to meet gate 2. So gate 1 is just asking for a connection, but not being able to evidence that kind of ready or needed bit, in which case you effectively get a kind of holding position. You're not in the queue, you're just in a kind of holding pen. In order to get that kind of contractual and commercial certainty, you need a gate 2 offer. So there you need to have demonstrated that you've got your land rights, you need to have demonstrated that you're sort of strategically aligned with the generation pots to show that you're needed, and then you would get a gate 2 offer. We're currently in the middle of that process. So generators and demand customers are all waiting for the sieving of the queue, which has just taken place, to kind of then precipitate out their new gate 2 offers. So that's that's where people are going to be making investment decisions. Ideally, once they've got their gate 2 offers, to say, is this project still viable for me? So I did have a contract that said this, and now I've got a contract which says something slightly different. And I guess people are frustrated because I think, the point of connections reform was to slim down that queue, which should mean that everyone's connections actually speed up. We're no longer planning for 750 gigawatts. We've got a much more streamlined pipeline, so we can do it more efficiently. So everyone was sort of told, well, you're going to get a new offer, but that offer should be better. And that's quite a nice pill to swallow. And I think, we'll maybe come on to it, but one of the challenges we're seeing now is actually this process has taken a long time. It's introduced a lot of uncertainty and a lot of delays, and people might be getting worse offers. And that's a real headache if you're an investor.
Yeah, because investors love uncertainty, right? They I think it's funny because I used to have the mental model of how lots of parts of the energy sector and development and building infrastructure is almost non-competitive. It's much like airplanes, like airline safety, right? Like it has to be done, so they all just collaborate on it and it all gets better, and it's not really a competitive edge. You just have to be safe. And it's a lot of energy developers are like, I don't care if you build your site faster, I just need to build my site fast. But the gate process, especially in recent years, like when I talk to developers, like they're fiercely competitive about trying to put their best foot forward and not share things. And I don't think it's not gone totally the other way, but it's funny how that's had a material impact on the way I think a lot of the developers we've spoken to think about other parties within the industry.
I guess connections reform creates winners and losers. It's that shaking of the sieve. So we had to set some criteria that were who's going to fall out of the queue, and that's really controversial. So I think that process in itself was always going to create winners and losers, and that's can polarize the industry. I think now that process is set, and it's kind of, for better or worse, those criteria are what they are. I think there's maybe a secondary kind of knock-on impact, which is now, if you're still sitting in that sieve, so you haven't been kicked out of the queue, you're in the new gate 2 queue, actually there is a concern that we've artificially reduced competition, and that might not be a good thing for consumers. So we've sort of said, oh, we only need this amount of wind, or we only need this amount of solar. And so when we've removed the rest from the queue. So does that mean actually those projects would have been like submitting bids in for a CFD? So what you've done is arguably artificially reduce the size of the market, and that might mean that some of the projects you kicked out they might have been cheaper or,
Yeah.
or more deliberate. So that is a controversial point as well.
Yeah, that's
Is
really
it going to have a market impact? I think it's a little bit outside my wheelhouse, to be honest, as an electrical engineer. I think it's really hard you can't design the network for everyone, knowing that 2/3 of them might never come along and connect. So yeah, it's a
that's interesting
line.
to think about it that way. And I guess like it's all current, right? The other thing is it's all happening right now. The system will reach steady state again. And it will kind of get back, but that's a way away and lots of money disappointment to get.
I suppose that kind of like sieving process, that is a one-time action, because what we're doing is applying these new rules retrospectively. Going forwards, that criteria will just be there. You'll have to clear that kind of gate too, so the new development world will optimize for that. And I think there's room for there's a lot of potential. In fact, NISO are consulting right now on they're very unsexy, but the methodology documents that sit behind all of this, and how they've kind of done that sort of shaking of the queue for this, we call it gate 2 to the whole queue exercise. So, effectively like retrospectively applying that. We are now at a process where they're sort of looking to say, was that a good way of doing it? Because by the way, when we do the next gate 2 window, maybe we could change some of these things. So like now is quite a good time for people to feed into that process. We like plugs for engagement.
No, yeah, good. So you've spoken before about how this is probably falling behind other parts of the energy sector with regards to automation. Do you want to expand on that a bit?
Yeah, no, definitely. And that's probably a much more, I've already gone off on a connections reform rant.
That's great.
But yeah, I think one of the process challenges, so connections reform has kind of thrown it into light. We've got this like volume challenge. So, we've got large numbers of offers that have to be produced, especially as part of this new gate 2 process. And so I think one question which comes up again and again is, well, can we automate stuff? Can we use AI? Yeah. Why can't we just use technology to do this better, faster, just sort it all out? Yeah, exactly. And we probably, I think this will be good because I think we probably have quite different opinions on this, Adam. I think I would differentiate between automation and AI. Would you agree?
I
guess I think from an engineering perspective, automation could be just any piece of software, so a system I set running to do a task automatically, but maybe using really set rules that I've given it. And it's not trying to learn anything or evolve, versus AI, which I think, where you're basically sort of saying, you learn and decide what the rules are yourself, AI, and then go nuts.
Yeah, I don't agree.
Okay.
Because of a nuance in definitions of AI and things like that. So I usually start from a position of who cares. I don't care if it's a magic genie that does it. Who cares, right? Because you want the outcome and you want it to be reliable and testable and all that. So if you do that, does it matter? And there is a bit of a misnomer, and everyone sees AI and thinks all AI will continually learn. But actually, that is a very specific flavor of AI called reinforcement learning that's quite hard to do, and isn't currently the de facto large language model AI, generative AI stuff. You would have to apply a reinforcement learner to do that. And we did a webinar yesterday, and I talk about a joke about AAI. It's one of my favorite terms, artificial intelligence, where it's a human pretending. You get it in these. There was a startup that went under recently, and it turned out it was a call center of 800 people that were just answering queries, and in a low cost country. And there's a humanoid robot startup that, again, it's 1,000 people in the Philippines manually controlling these robots and stuff. And so that AAI is an interesting term. And so what is happening today with AI learning? And you get a lot of value from this. How often do you need it to learn? Do you need it to learn every minute or once a quarter? Because if it's once a quarter, AI is good enough. Watch what happened and have humans inject new rules and processes, right? We will trend towards that continual learning stuff. And the other change that we're seeing at the moment with the kind of distinction of traditional machine learning and AI, as in AI, we've now rebranded to just mean large language models and generative AI, is... I talk about how some of the biggest, most well-funded, highest market cap companies that have ever existed, everyone I've ever met, 1,000 people times the smartest person I've ever met, all work in one group at one of these companies, and they're fighting this like Godzilla versus King Kong battle to build the best model. That's unstoppable. That's just happening.
Yeah.
That's daft. But that's like
we don't necessarily need to design our electricity network.
No, so they're building the kind of general engine that makes the general brain smarter of it all. So you're going to get that increase for free. Like that's going to happen whether you like it or not. So if you can build intelligent automation and leverage some of this tooling today and safely and securely and put the right bounds around it, it will just get better for nothing, because like loads of daft VC and private equity companies are pouring billions into it. Anthropic just raised 30 billion quid or dollars, sorry, to fight in this fight, right? On top, valued at 380 billion. So is AI automation continual learning? I would say no. But I think if we zoom back out to what most people mean, they mean plug it into AI and it will just learn and do it.
Okay.
That I think is daft.
Yeah. So, and I think we probably agree on that. And in terms of the reason for making that differentiation is that I think there are two kind of different angles for how, could this help in the grid sector? And I mean, I'll make the first kind of controversial comment, which is that actually right now, I think the answer is no. And for two kind of specific reasons. One is that AI cannot physically build anything.
No.
So AI is not going to help us build new substations. It's not going to be up there like stringing an overhead line in the midst of winter in Scotland. Like a lot of the critical path activities we have at the moment, the reason, your hospital gets told it has to wait 6 years for its grid connection, which is not a good answer, right, for, the NHS. Those are the critical path activities. A lot of them are physical, manual tasks. AI just doesn't help that. AI can actively hinder it potentially, because if you break those critical paths kind of down, you've basically got a task which is really hard about kind of actually physically manufacturing and installing kit. And you've got a task at the beginning, which is basically around getting things like very large substations consented, and that's, I'm really kind of fiercely protective of the sort of like the need for that to be a human, that's sort of, engaging with a community that's going to be affected. And we've seen, I mean, AI has had an impact already in things like, if it's possible for one person to generate 50,000 objections to a substation, it's that can be huge. So it's making sure we're not kind of like swaying or unduly influencing kind of, the democratic processes that are pretty fundamental. Because I think, we have to take people with us on this journey. Like you can't just force someone to have a substation in their back garden. So I think AI doesn't help with that physical kind of construction and build out of grid. I think the other thing is that, I think we've spoken before, Adam, about the fact that the grid connection process itself, I guess it's got harder, but it's also got more opaque. So you're basically asking for a grid connection, and it's kind of, it already feels a bit like it's kind of going into the black box of, a very large, maybe like national transmission operator who's sort of doing some studies in the background and coming out and saying, yeah, you can connect in 2037, and this is the cost, and this is why, and that can feel really, people say, well, why? I don't understand why. And actually, at the moment, even what you've got behind that is a power systems engineer who's doing some network studying. So they're modelling. So they are, they're using automated tools, but they are modelling what the grid's going to look like, what the impact of connecting your specific, say, data center is, which elements of the grid need to overload and so on. And they're doing that using sort of industry assumptions. So we have to have some assumptions about what the future network looks like. Current data, so how heavily loaded is the existing network, and some kind of engineering rules about what we think is okay. And I think there's a real value in being able to grill that engineer and say, look, if we flex one of those things, would the answer change? How confident are we about this thing? And I think if you tried to automate more of that process and remove the human content, you might be able to do it efficiently. You might get 10% of it very, very wrong, but the problem is you would lose the trust of the people who rely on it, and they would say, how can I be confident this is right? No one's able to explain it to me. And we're kind of already in that situation at the moment. There's been, developers are very frustrated because there's been a bit of a sort of embargo on the normal communication routes, and you see that really affect industry confidence. So I think it's interesting that there is something that possibly technically, machine learning could help with, but it might be a hindrance in the short term.
And it reflects, like, early on in my time in energy, I was building virtual power plants, and we did some clever stuff for optimization. I always say this all the time on the podcast, but optimization's a bit of a dirty word in energy, in my opinion, because it usually means sometimes we'll turn it off. Like, it's not capital O optimization, which is like actually what's the optimal set of decisions to be made. And we built these optimizers, like real mathsy boffin stuff, good fun, and then took it to the market. And this was a good 5, 6, 7 years ago, and no one wanted it. Like, none of the developers wanted it or the owner operators wanted it for their assets, because effectively if it did something wrong,
they didn't know why or who to blame. Yeah.
Why did it do that? Well, the highest peak in this n-dimensional mountain range is over there. So that's why. Whereas they want, like, okay, give me 1,000 if-else statements, and then I can point at that when I'm on trial with the board of investors or whatever. And we're seeing that change a little bit. But do you want to go through that at a system level? Like, that is pretty terrifying. And we are seeing it play out in kind of non-energy big tech kind of AI stuff. Everyone's hot for it. There's an agenda being pushed, but the winners, I think, are the people that are now saying, well, okay, I, as the engineer, the software engineering is really interesting. It's like the one thing everyone's going for. I, as the engineer, instead of sitting down and coding up the solution to the requirements that I've got for the day, I'm going to press a button and have a swarm of 20 agents battle it out to code that up, review each other's work. And then when they're done, which will be in about 2 minutes, they're going to send me something to review. And that is a nice process, because they're going to do 2 minutes is short, but they're going to do maybe 5 or 6 days worth of coding. But there is a right and a wrong answer that human can be the stage gate, and you'll see people try and then automate the review process. I think that's daft and we're way off, but that kind of process might be interesting to see. But again, gently, softly, like, what's the smallest, lowest risk environment to do that in? And we talked a little bit before about why haven't we got a sandbox, a safe sort of digital twin, something that actually is backed and everyone can then engineer and test against, that would allow us to do scenario planning and what ifs and modeling and optimization
and grow industry confidence. I like this idea of a digital twin. So, and I think it's a bit of a buzzword, isn't it? But I think that a lot of people assume we have a digital twin, so effectively like a computer model that is simulating and reflecting what is happening on our national grid all the time. So it's worth saying we don't have that. Yeah. We have a computer model which is a power system approximation of the national grid, for example, and each distribute.
And can I just say, I did physics because EEE maths was too hard at uni, so I looked at the maths and I thought no tar, and I just did like
someone who did stuff about lasers.
Yeah, I did theoretical physics because the maths in EEE was too difficult. So like for people that aren't aware, it's really hard to model electrical systems, right?
Yeah, and we do use. I think that I would like to make it clear, I'm not anti-automation in the sense that I think engineers need to be writing out millions of lines of reps and rafts and iteration. In order to do a kind of power flow, we have great computer simulation programs, but the key thing is that they are snapshots. So effectively, like, you're building a model which is an approximation of the transmission network at a moment in time. So that would include things like which substations and overhead lines and so on. What's the rating of those overhead lines? Have they been upgraded yet? So, imagine you're sitting there in your perhaps national grid transmission in England and Wales. They own the infrastructure, and they might have sort of, some models which say, right, well, in 2026, this is what the grid currently looks like. And in 2027, we'll have done some more reinforcement. So we'll have another model that shows what happens in 2027. And we'll have some iterations, some tunes we can play on those models to show at any moment in time what would power flows look like. We won't do every moment in time because that would be silly. So instead we'll pick what does it look like on a windy day in winter when there's lots of wind farms in Scotland operating? What does it look like on a sunny day? What does it look like on a kind of a high pressure, really cold snap, we've got no wind and we're burning all the gas. And obviously because those assets are located in different places, that results in different power flows. So those are like snapshots. But what we don't do is continually monitor all flows on every asset in the grid, which is what you'd need to do to basically create that digital twin. And I think there is a question to say, should we be putting loads of effort into monitoring. So, actual kind of like monitoring units that are collecting that data so that in a couple of years' time, you could build that digital twin. And I think that because we have that information on other areas in the market, like if you did and I know you guys do a lot of work at Hypercube, don't you, on the energy market side, and that data is there. We know exactly how much energy got sold by this producer for how much and so on. So, if that data was there for power flows on the power system, we'd be in a different place probably in terms of automation.
Yeah. And I think the painful bit is there are almost certainly 20, 30, 40-year-old computers sat in a field somewhere that have each individual element of that data on it for periods. Like something somewhere is doing it, there is a system monitoring something, and you don't need the perfect information if you have enough of it, if you have enough of a sort of confluence of that info. It's just not connected. It's all owned by private entities. It's all it's just not easily accessible because the digitalization of the energy sector is a bit behind, and we are starting to think about it.
Yeah, though, I mean, again, possibly controversial opinion, though, we should maybe be quite thankful that some of that stuff is sat on a 40-year-old computer that's not connected to the internet in a field somewhere. It is the reason that the national grid is quite unhackable at the moment because of that sort of like isolation. So I suppose if I was starting at this from with my very AI skeptic engineering brain saying, no, we should trust humans and humans learn from this stuff. And, and if we just, sort of set AI at it, AI won't notice all of the rubbish data and so on. If I kind of had to sort of pick where would I start, I wouldn't start with the high risk, big transmission system. I think there's partly because they've got other stuff to do, right? Like those transmission operators, they are going to be busy in the next 10 years building a huge amount of infrastructure. And I think we can live with that snapshot model approach. I think it's a good kind of 80-20, you put in, so you get 80% of the answer with 20% of the effort. So I think we leave the transmission system alone, but we were talking earlier about the opposite end of the spectrum. What about like the low voltage networks, like the wires in the street outside your house? If those are things which we do not, I mean, we don't have a digital twin of, we don't even have a digital model of them half the time. Exactly. It's a paper drawing somewhere in a basement. And that it would be, because we're starting now from almost ground zero on some of that stuff, the digitization of those records and so on could be really complicated to do. And we'd be putting an awful lot of effort into just creating that snapshot version. So maybe on the lower voltage, smaller stuff, we should be instead directing that effort into monitoring and saying, you know what, forget trying to an engineer to work out what's the impedance of this bit of cable between my house and your house. Actually, just stick some measuring on there. You've already got smart meter data, watch it, and you can infer the impedance in real time. So I think that could be really interesting. Digital twins of sort of low voltage, high like the lower voltage distribution network.
Yeah, and I think so. The frustrating thing about that is, imagine the smart meter rollout actually worked and we actually did it and did a good job of that. Like, that's been such a shame that there's other economies and countries and stuff doing it now, having learned some lessons from what's happened here, where it's just not been like hard mandated and it's not been left to private entities. And I think it's not a missed opportunity. There's great data there, it's really useful, but even like working with DCC and stuff, that they're going through a digitization and a cloud adoption process, and there's barriers to entry there. But you go to like the electrification of vehicles or heat and things like that, and there's suppliers out there, we've had some of them on this podcast, talk about how actually they've got like 250, 300,000 homes, they've got super over-spec'd Wi-Fi connected meters for their EV charging fleet. They have brilliant models of that low voltage network, and actually they can infer things about the transmission network because they cover such a broad, like they've got the physical model of what is where, and they can say, right, well, this is outperforming that and here's where it is. But there's not really a mechanism for getting that out of their hands back into the kind of central knowledge base.
Yeah, and I do think you would need to link it up a little bit. There are some missing bits of data there because we've got so much stuff that's in people's homes, but not very much that everyone's homes connect into a secondary substation, we'd call it, which is, probably looks like sort of green cabinet, maybe at the end of your street. And no one's monitoring that, if you see what I mean. And then the kind of upstream sort of primary substations that might be like, one per sort of large village or small town. I think what can get lost is it can be quite easy to see like a national picture. The frequency, for example, gets monitored in lots of different places, and it can sort of show you what's happening in terms of sort of the inertia on the system. that's not actually the information we need to know. If you write to your local network operator and say, I'd like to put in a heat pump and an EV charger, please, can you tell me whether my supply to my house good enough for that? They don't care about the inertia of the network. What they care about is the cable outside your house going to get too hot, and is that transformer back at that secondary substation going to explode because you've overloaded it? So we need some extra bits of monitoring, which the DNOs, they do a lot more monitoring, but like you say, it's not joined up with those other sources of information.
And you've kind of hit the nail on the head in just that answer. In that, like, how many sort of entities have we just talked about there, like DNO transmission, the homeowner? There's so many. Every time you add another person, you get to Dunbar's number of, like, you can't even communicate because there's too many of us trying to get things moving. And
yeah, I think we could see network operators, so the distribution network operators, they might be some of the drivers behind that coordination. Smart meter data is really useful for them, and they do get to see it in a kind of aggregated, anonymized version. So I think there could be developments in that which could help move us forwards. But it's a really interesting space because it's basically less sexy than the big transmission infrastructure, so we don't talk about it as much. But it's definitely an area for improvement.
Yeah, but less risk. So we've done away with the grid reform. We've automated the whole energy system.
Well, Adam has. I've like.
How far, what about Clean Power 2030 then? Like, that looks bonkers when you look at some of the numbers and some of the things that we need to achieve.
The official Hypercube.
Yeah, but like, it feels like we're maybe doing it.
Yeah, I think people. So Clean Power 2030. Just to be clear, like, that's it's a very clear Labour government objective at the moment. Who knows whether that will change, in future with a different, if we do have a different government. So I think and that's a clear ambition to decarbonise the electricity sector. Electricity sector is already doing quite well in terms of decarbonisation, but it is still a big goal to get to decarbonise by 2030. So we've set out this pretty ambitious plan that says, we're going to build more offshore wind, we're going to build more solar, we're going to build more renewables, and we're not going to build any more gas unless it's kind of got carbon capture or storage associated with it. Those are big, bold ambitions. And I think, being pragmatic from a grid connection perspective, we're not on track to meet that. But I think, is that natural? Maybe it is good to go with a bold target. It focuses. And if we meet 80% of that, 70% of that, I think we will have done an amazing job.
Yeah, 100%. Like, favorite books on strategy, Good Strategy, Bad Strategy, talks about objectives that are close to where you want to get to and just going for them, because the classic example is the space race and the moon landing, and saying, right, by the end of the decade, we'll be on the moon. And okay, then you just organise. It gives everyone an organising principle to go after a thing and look at all if they hadn't landed on the moon or beat the Russians in the race, they still would have had all these technological advancements. So I totally think it's a valid thing to have tried to achieve, but it feels like we might do it.
I think no one's sitting down and saying this is impossible. I think it's very hard to see how we would build all of that infrastructure in time for 2030 at the moment. There were several things which both the network companies and generators called for in terms of sort of reform to things like planning standards and stuff, which has been quite slow to come. So I think a lot of people would argue they've kind of been given the goal and not been given some of the tools to get there. But I think one thing which is really important to highlight is that the Clean Power 2030 set this really clear target, which is having other benefits. That's the side benefits of being bold and saying we need to build this grid. Because in practice, you are now encouraging grid reinforcement, which is not just going to serve clean power technologies. Yeah. It's also, we need that grid to be able to power the data center in Slough, right? The hospital, actually kind of just giving the green light and more certainty to the industry that what we need to do now is build does have ancillary benefits. I think we're wrong sometimes to overly simplify it and say we're doing this to be green. We're not really doing it to be green. We're doing it to keep the lights on, and keep the economy going.
Yeah. There was a thing I saw years ago. I went to a talk for someone that had done a study, and it was bonkers numbers that were verifiable about how, I think I'm going to get the specifics wrong, but it was a port they'd looked at and the sort of decarbonisation of this port. And they basically found out or concluded that for every pound spent on that decarbonisation, on green, they got £38 return in ancillary benefits, not even on the initial like money saving, all that, but on the local stuff. Like when you look at second and third order effects, local communities, the investment, all the changes that go around. It was just for a single port in the UK. They got 38 times return on the secondary effects. And I think like I've not seen a study like that for the clean power stuff on the national scale. I think everyone's got this warm fuzzy, we should be green, clean power feeling, but I was told years ago, and I think it's a very pragmatic view of sort of net zero and climate change, and I believe it, is that like we've talked about some of these parties already, but some of the people building this infrastructure are just money people. They're just like pension funds. They've just got money, make the money go up. That's it. And so by doing it, you're just making these huge pots of money bigger, right? And that's the very like financial kind of corporate evil overlord view of things. But the day everyone settles on the fact that like green electrons more profitable than any other kind, Wall Street will solve the problem for us, because all the money will just start to flood in and we'll get more challenge, more investment, and the snowball will get rolling. And I believe that to be the case. And it won't happen overnight. There's like real constraints and physical things, but when that overbearing pressure of investment appears, as you've seen with AI recently, like industries, governments, systems move pretty quickly if with enough pressure.
Yeah, I suppose that moving quickly and being agile, Clean Power 2030 is perhaps not a particularly agile plan. It's a static target, effectively. So there's a target for 2030 and there's a target for 2035. And in the grid world, those translate to specific megawatt volumes of offshore wind, of different types of generation, for example. I think, one thing, there's the kind of the adage, like all plans are wrong, some plans are useful. Hopefully it's sort of it's been a useful tool in getting that kind of industry momentum going to say, yes, we need to build stuff. And also it's a tool that we've used to revise the grid queue, but it is quite a coarse tool. I think there's a good Modo stat, which was that the forecast for energy storage systems within Clean Power 2030. Clean Power 2030 basically says we need about, sort of 25, 28 gigawatts of batteries by 2030, and then we don't need any more. And they sort of unpicked that stat and went, well, that's interesting. We think you need a few more. So what cost? What did you assume for like the cost of a battery? And then they said, oh, it's about, that cost is 4 times what the current market per megawatt hour cost of a battery is. So plans are wrong because the data that they're used
immediately outdated.
They're out of date. Yeah. So I think one key thing is going to be, how do we move for? We need more plans, and there is the next kind of update to that Clean Power plan from a networks and grid perspective is the strategic Spatial Energy Plan, the SSEP. We love acronyms. And that, again, is like, it's the next version of sort of saying, how much, wind versus solar versus batteries do we need, and where do we need it? So it's got that spatial element to it. So I think it's just it feels like an interesting time where, grid, NESO, government are clearly quite comfortably kind of moving more towards that sort of centralised planning role and less towards that market solution that you mentioned. So it'll be interesting to see which went out.
It's actually quite fun. It's so easy to just sit and go, that's wrong and that needs done differently and that. But like, actually, at the end of the day, there's good reasons all this stuff happens the way it happens, and it is naturally messy. And it's like, you make a plan, you do a thing, and then the reality is different, and everything has to move, and that all just takes time. And it's humans and it's professionals. Like, no one's purposefully trying to do a bad job of any of it. Like, it's just a challenge, right? It's a hard, complicated problem with lots of vested interest from competitive parties. I mean, for you, like, what would meaningful progress for the next few years look like?
So I think we have to get faster at doing both the kind of reforming of the queue. So this year is absolutely critical. We need to get those gate 2 offers out to customers so that they can progress with their commercial certainty and build projects. If you're building a project, a large scale project connecting the transmission system this side of 2030, you need to be starting ordering kit. You need to have your planning consent already. So, actually that pace of, it's pretty much business as usual activities, but because of this big reform, we've sort of paused it all and we've got this backlog of work. So we need to really be able to deliver at pace this year on the kind of contractual side, and then delivering the infrastructure at pace, I think. So I think the kind of, we need to get stuff kick-started into delivery now. And then I think we need to the next challenge is how do we be a bit more agile for those future plans?
Hard one, I think. This has been amazing. Thank you so much for coming on. I always ask the same question before I let anyone leave the room. If anyone in the audience wants to find out more about you or Roadnight Taylor, or if there's actually anything you want to promote or plug, where should we point them?
So Roadnight Taylor, well, we have a podcast of our own.
Yeah.
So the Connectology podcast, which is more of this great geeky stuff. But we also, Roadnight Taylor have a whole series of sort of connectology materials, so explainers and things like that. So if anyone's kind of quite interested in some of the geeky terminology or some of the grid process stuff, there's a lot of good stuff on our website that we try and disseminate for free, because we think, generally speaking, everyone getting a bit more educated about grid is fantastic for the industry. So tune into the Connectology podcast.
No, look, this has been amazing. I think we could probably do this for another couple of hours and not get any further through the question list. So this has been great. Thank you so much for coming and seeing us here in Glasgow, and look forward to the next episodes of Connectology.
Thank you so much for having me, Adam. It's been a pleasure.
Thank you once again for listening to the Hypercube Energy Podcast. As always, if you have any feedback or comments, or you want to get involved, please get in touch. And if you want to find out more about what's happening in data and AI across the energy sector, please join the Beyond Energy community. And I look forward to speaking to you soon.